Hi there, my name's Vince from mymatevince.com, and in this video today it's going to be a revisit on the Robotic vacuum cleaner. So I released a video earlier today. It seems to be doing well in relation to thumbs up to thumbs down, so that's always a good sign. So this is the revisit video where basically I'm going to be refitting the Schottky, that's how you pronounce it. I'll show you a sheet with some comments and stuff later on, but yeah, I need to replace that. Now, I've been using this for a few days now and it works well apart from one major problem, and that major problem is every time you turn it on, look, that will spin like that. And you might think, well, that's not such a big deal because when it's moving around the place they're both spinning. The problem is, the idea is that when the battery gets low it finds its dock. So when you turn it on the light's blue, I think, when it's whizzing around the place, and then what happens is it goes to amber when the battery's dying, and then it makes its way back to the dock. It can sometimes take a long time, and reading the reviews online, sometimes it doesn't make it back to the dock at all. In the few times that I've used it, I've let this go round for about a good 45 minutes to an hour. It really does last a long time, and then it works its way back to the dock, which is great. The problem is, when you look at the dock, this thing is still spinning because this will always spin every time it's on. So when it's off, I can charge it up fine. So if you have a look now, if I plug the charger in, when this is off, it will charge up fine. So it is still completely usable. It just means it's not as automated as it should be. So look, you can see that's not spinning now. But imagine now if it was zooming around a place doing its cleaning. So pretend now. So I'm going to turn it on. You can see that they're both, well, that's going, but look, turn it on, and they're both going. So now I'm going to force it to dock itself. There, that's still going. So it's charging and going at the same time, which is wrong until we turn it off at the bottom. But you shouldn't have to turn it off at the bottom, because the whole point is it's all automated. So it just goes around, does its job, docks itself, and the next day at the same time, or however you set it, it will go out and do its job again, or when you turn on the remote or turn it on here. So we can't have this constantly spinning. It shouldn't be spinning. So that is a fault. So in this revisit video, I want to change the diode over. That might well fix the problem, but I don't believe it is, because most people said that's just a reverse polarity to stop protection for reverse polarity. So I don't think that's going to cause this problem. But if you remember, it's this one here that's spinning, and I think the circuit board was damaged on this side here. I've kind of forgotten how it went back together, but if it was, it might well mean that there's something else not working properly in this water damage section. The reason I'm hopeful about fixing it is I'm hoping that whatever chip controls this, there might be the same sort of chip on this side controlling this, or I might be able to compare the diodes and the resistors and capacitors that feed this one, because this side should be behaving exactly like this, but it's not. And if I can compare between the two, hopefully I might be able to see the difference, and then I might well be able to fix it. So what we're going to do is we're going to take it apart, swap that diode over, put it back together, turn it on, see if that's still spinning like that. If it is, we know it's not fixed, and we can fault find it further. So basically, reading the comments on the videos that's just been released, remember I wasn't sure how to pronounce the batteries, so they're basically called 18650s, and they're roughly 18mm long and 18mm in diameter and 65mm long. And that comment was by Disco Crisco, which is a great name. Now, loads of people told me how to pronounce it. It should be pronounced Schottky, because I didn't know how to pronounce it before. Yeah, I was like Skotsky or something. I'm not sure what I was saying before, but it's Schottky, and I understand now how they basically work. So let's just, so many people have commented this, so I haven't written all the names down because loads of people have, so thanks to everybody that did comment. You know who you are. So basically these Schottky ones have a lower voltage drop. Now that's easy to say if you know what that means, but the great thing about the comments is so many people have explained it in a kind of idiot-proof way, so people like myself can understand it. So pretend now you've got 9 volts going into the diode. It could be anything, it could be 5 volts, whatever. But you've got 9 volts, let's just pretend in this example we've got 9 volts going in. So with a Schottky one, you might get 8.7 volts coming out. There's always a bit of a voltage drop, yeah? But on a normal diode with 9 volts going in, you might only get 8.4 volts going out. So these must be more like energy, you know, energy efficient. They mustn't waste as much energy through heat and stuff like that. So basically, if voltage was important in a circuit to have a higher voltage, then you would need to put a Schottky one in. So that's really good. In this instance here on this setup, a lot of people said it's just being used for reverse polarity protection. In other words, do you know on the last one when I measured this adapter here, I said that the middle was positive and the outer was negative? Well, let's say some adapters like this, the outer can be positive and the middle negative. In which case then, if that was put in there instead, or if somehow it managed to dock itself the wrong way round, which isn't really going to happen, but if you were to put it on its home this way round rather than driving it up, if you were to force it down this way or something, then that's what that diode would do. It would stop it from blowing from reverse polarity. And also a Schottky one will react quicker, so it opens quicker, because apparently diodes take a tiny amount of time to open, but a Schottky one will allow that to go quicker than just a normal diode. And the coating, remember I said it's got a funny coating on it, and when I was cleaning it, it was kind of like a rubbery coating. That's called conformal coating, which acts as a waterproofing. Obviously this was heavily damaged, so it's not going to create a miracle, but it allows a little bit of protection to the board, or maybe quite a bit of protection to the board, so it's definitely a good thing. Apparently you can buy conformal coating in a spray that you can spray on it, and 2 people, Delph and Grandpa's Place, confirmed that the brush shouldn't be spinning, which I kind of guessed, but it's always nice to have confirmation, isn't it? So I didn't write down all the names here, and since the video's been released, even now when I'm filming this, there's probably more and more comments coming through. So I appreciate it. I can't obviously list names in every single video, because the whole video will just be a kind of big thank you video rather than the actual content which people watch. So but every now and then I do sort of drop a few names, but whether I drop names or not, I appreciate, and not just me, other people reading it. It helps everybody by giving good comments, because then we all learn more. So that is it. So let's take this apart, and I'm going to use my hot tweezers to get the... No, I don't need to use my hot tweezers, do I? Because I'm removing my big diode that I put in. I'm just going to use my soldering iron, and then I'm even going to put this in with the soldering iron as well. I'm not going to mess around with the tweezers today. So I'm going to fast forward through the dismantling of this. To begin with, I'm not going to remove the board. I think I'm just going to do it with everything in situ here. Then if it doesn't work, I can remove the board and start the fault finding from. It's this motor here, isn't it? So this is the one that keeps on spinning. So we can fault find from this connector and possibly compare it to this connector here to see, what the difference is between them. Why is this on all the time as soon as we turn it on, and this one's not? So maybe the capacitor's faulty, or I don't know what would cause it to only come on when it needs to. Do you know what I mean? It's strange. This is, I don't think it's anything to do with the chip. I mean, this is definitely water damaged over here, so it looks like there's more than one component that's damaged, or maybe something else is missing that I haven't spotted. Because I did get a couple of comments about missing thingies, but I definitely know when I was editing it, one of these looked missing. I can see now, like C13. Let me zoom in. But the problem is, a lot of the time, I mean, there's loads of missing components here, and there's no water damage here. So a lot of the time, there can be missing things on it, even when it's left the factory. But they're not missing. They weren't ever supposed to be there. They might have been taken out for whatever reason. Right. So we've got the. This is the one here. Right brush motor. So I suppose I'd need to start tracing back, but we don't have to worry about that yet. Let me just show you those ones that might be missing. You see here, C33. Loads of stuff missing around here as well. But again, probably supposed to be. Don't know. Well, let's remove this capacitor. Diode, and we'll pop the new one in. Right, so we've got the band of the diode here, so once my soldering iron's heated up, I'm going to be putting this new one on with the band there. And you can see it says SK34. This one doesn't say A on it, and also it's a lot bigger than the ones I removed. This was the original size of the one, but I presume they're doing the same thing. Do you know what? I'm not sure if this new one's going to fit in because of the resistor next to it and that capacitor. Let's have a look. God, it's massive, isn't it? Right, so how am I going to do this? I'm going to have to do it on top of them and just hope that the pads underneath connect. So I'm going to have to leave massive blobs of solder. How else can I do that? Unless, hold on, maybe I can put it down here and swap that one back. See if there's going to be room here for it. Yeah, I suppose we'll have to put that there. Yeah, okay. Well, in which case then, let's use the soldering tweezers to take that off and try to put it on here. I just need to remember to swap it round so the band's facing the opposite way. That's a shame. Right, okay, let's try and remove this now. There we go, and now I'm just going to try to swap it round straight away. Just try to get the camera do you know what, I think that dropped on nicely first time. Amazing, and I managed to swap it round. Wow, okay, that was extremely lucky. Right, now let's try to get this massive fat one on. I think I'm just going to use a soldering iron for this. I'm going to use some braid and I'm going to clean up the, which one should I clean up? What would be easier for me? I suppose cleaning up this one here. I'm cleaning up one of the pads so that it will lie nice and flat. This thing is massive. Don't really know how much of a good connection that's made against that bottom pad. I did try to put the soldering iron underneath it, but I can't see any of it at all. This really is huge. Do you know what? I'm going to have to put solder under it because I'm not going to get to the pad. So I am going to have to tin up the pads underneath. Do you know what, I suppose if that one makes a connection, as long as I solder that one to this one here, it's all on the same rail anyway. So if I just put a big blob of solder in here, it should still make all the connection. Right, okay, now I don't know if that has made any connection at all, but what I can do is I can zoom out, I can get my meter, and then I can go between, for example, this, maybe this pad here, and then wherever this goes off to down in this direction. Because it goes, well, we know it goes to this one here, don't we? So if I measure between here and here, then I should have that 0.2 volts or whatever it was, the voltage drop before. And then I know whether it's actually made a connection with the pads itself. So that's diode test. Right, so it's not giving me any reading. Swap the leads. Okay, 0.17. Let's see what its neighbour's doing. 0.18. Fine. Excellent. Okay, so I know it's not. I know it's not great. I don't really know how I could have ordered that any differently, because I suppose the other one said SK34A, so A must be a lot smaller package than just SK34. Yeah, so I suppose in hindsight maybe I should have looked around and maybe bought off a seller that mentioned the dimensions off it. Well, okay, let's just double check that this one is connected, this other diode that I swapped over. 0.19, and nothing that way. Right, so we can just pop the battery straight back in, and I think it will work without the top. We'll just see if it's spinning constantly. If it is, we'll have to do some further fault finding. Right, here goes. Okay, so we know it's not fixed. So now let's actually do some fault finding to find out why. In a way, I'm pleased that it's not fixed, because it means we can look into it further. So we've got constant power going to it. I'm wondering if I can do all my fault finding from the top here without taking it apart, because most of the traces were on the top. So what I'm going to do to begin with is I'm just going to look closely with my, well, let me zoom in and I can show you guys, and then I can kind of just look closely myself and see what's happening with it. Right, so that's the connection there. Let's just get the meter on continuity. So this whole trace underneath looks like it's going to be the negative. So if I was to go to here, that should beep. Yeah, okay. So now this positive one is getting power all the time. So this one looks like it's going to this side of the capacitor. No, it doesn't. Right, so we're going to that side of the resistor. So I should, let's work this out now. 2 with 1 0, so that should be just 22 ohms, shouldn't it? So let's get the meter. Let's see what we got. .7 ohms. Yeah, 0.7 ohms. Okay, maybe that's right, I don't know. So that means we should get a short across here. Yeah. So where does it go to then? Can't really see. It's a flux here from when I was cleaning all the corrosion off. Yeah, okay, so what I'm going to do is I'm finding it hard to see. So I'm going to get the eye loop on this just to see if I can work out where the traces go. So it looks like from here it then works its way. Does it work its way down here? There. Yeah, okay, so I'm going to do probably most of this off camera, just looking for my eye loop and also taking measurements against this side here, because remember we can just trace the wires from here and see where they go to. So you can see again we've got a small capacitor. Well, there you go, we've got a resistor there. In fact, let me measure this resistor here, and then that will tell us, because we know this side's working okay, that will tell us whether that is measuring the same as the other side or not. I'm not getting any reading at all, but it could be because of the conformal coating. Here we go. You really have to go down hard. So that's 1.4. 1.4, so it's quite then again, is that going to make a difference? 3/4 of an ohm? I don't know. Anyway, that's what I'm going to do. I'm just going to compare both sides and see if I can find out what it is that's causing it. And also, while I'm here, I might as well clean this all up with IPA. Just cleaned them up, the ones that I soldered now. Just want to double check, because this diode's so big, I want to make sure it's not hitting against that resistor there, which it's not. Right, okay, what I'm going to do is I'm going to take the board out. I'll tell you why I'm struggling with the readings. So for example, there's a diode very near this motor. I'm not sure if it's connected or not because it's so hard to see the traces with the conformal coating on, or the reflections, and when it's blue on blue. But if you have a listen, just normal continuity, I noticed on the diode test I was getting similar readings, and look, shorting that way on the diode and also that way. But got my hopes up, but it's exactly the same on this one here. So I think it's because I've got all the motors and stuff connected that basically, for all I know, it could be just shorting through the actual motor itself. Do you know what I mean? Yeah. So let me disconnect everything from the board and then I'll be able to fault find it properly. Right, okay, so now this will make it easier for me to work on. Find out what's happening over this side here. Right, okay, I've been trying to compare this area here with this area here. Now, it is a different layout, but if you look, the components are the same. So for example, we got a resistor 220, and we got a resistor 220, we have a diode here, capacitor, and this MOSFET, and this MOSFET. So basically these MOSFETs are both labelled up at the same thing, and they are FR9024N. Now looking at the data sheet, it could be wrong, but this one looks to be the source, this one looks to be the gate, and this one looks to be the drain. Now I've looked up online how to test a MOSFET, and the weird thing is the test isn't working on either of them, and we know that basically this side's definitely working, and we know that this side is not working. But what is interesting is they're both giving me different readings, and as well as that, there's a tiny little resistor. Annoyingly, it's one of the smallest ones on the board, and I'm not getting any reading across it. And that's the one that feeds this leg here, which I think is the source. But yet, on this one here, it looks like it goes through the board to a via. I think it's this one here, which then goes up to what I believe to be this side off the same resistor. Then after that resistor, it goes to another resistor which is labelled up as, 1 second, 202. So that means 20 with 2 zeros, which is 2000 ohms. And if I get my multimeter here, watch this. So if I go on the one that says 202, it's so hard because of the conformal coating, but there you go, look, 2000 ohms, or 1.98, so 1985 ohms. Yet if I go across the same one on this side, the 202, and this is the bigger of the two resistors, can you see it's not giving me any reading? I'm pushing down hard on the board and I'm actually going on the resistor. So it looks like there's like a few things that look blown. So there's that one that's not giving me a reading, and the resistor underneath which is not giving me a reading. I can zoom in a minute. And yet if I go onto that resistor that feeds that 202 resistor on this side, hold on, it's giving me a reading of 55 ohms or 56 ohms. And I also want to show you this MOSFET here, and then I can zoom in. So let's put it to diode test. And watch this, I'll do it both way around, but if I go on to what I believe is the source and the drain, red lead on the source, can you see it's not giving me anything? And I'm pressing down hard, and then if I go the other way around with the black lead on the source, there's nothing happening. Yeah, but yet on this side there is. So the right hand side seems to be okay, so I've just got the black lead on the gate, the red lead on the drain, and you can see I'm getting something on my meter there. And if I go, I should do it again, yeah, and then if I go this way around with the red lead down here, and that's up there, yeah, I'm getting that sort of reading. But if I go onto this one over here and do the side that didn't do anything here, to the left hand side, you can see nothing's happening there. But now let's swap the leads over, and you see it's giving me something. Yeah, and now let's go on to the other one, and again it's giving me something. But if I go this way, it's not. So it looks like there could possibly be a few faults. I mean, the resistor's not giving a reading. It's definitely dodgy. Let me zoom right in on them so you can see. Right, so you can see in here the one that says 202. I'm definitely on them. Oops. Oh. Let me just see. I've probably just scraped that off completely. Hold on. No, I've scraped through the top of it. It's because I'm using so much force to try to get through all the mess. Where have I gone now? Luckily this was the one that doesn't appear to be working anyway. I'm not getting any reading there whatsoever. And the same with this one. So I think what I'm going to do is I'm going to see if I can swap these two out, and I think I'm going to swap over the MOSFET with the one on the other side. But you know what I'm going to do? I'm just going to completely swap components from one side to another and then see if the fault comes on this side or not. I mean, there might be further things wrong with it as well. The only problem is it's going to be quite hard for me. I think I am going to use hot air because that MOSFET's going to be quite hard to remove. Unless, do you know what I could do actually? I could use a soldering iron. I could maybe bend it up. Yeah, I really don't want to use hot air on this because of all the plastic. So I'm going to try to use just flux and the soldering iron, and I might get away with it. Right, let's start with this MOSFET, see if I can get one. So this is the suspect one. But maybe it's everything else on the board that's affecting the readings. I really don't know. Let's see if I can get that off at all. Do you know what? Maybe I should use a little bit of braid, and that might suck up a little bit of the solder. Might be worth a try. Can't see how I'm going to get that all unsoldered at the same time without knocking everything else off the board. Let me try and get the legs up. Okay, so that came up, I believe. Yep. Okay, and that's up, so now, hopefully, I will be able to lever it up. Oh, I've just broken it. I've just broken that leg off. I wonder, did I do that, or was it already done? I mean, to be fair, that was the side that wasn't given a reading, wasn't it? That seemed to break very easy. Maybe that's why it wasn't working. Anyway, let's try to get the rest off. Or is this whole thing soldered underneath? Maybe there's a massive heat sink underneath here. Yeah, do you know what? There's going to be a massive heat sink under that, I bet. Let me have a close look. Right, I can't see. I'm going to have to use hot air on it. Unless it's... I wonder, would it be glued down in the middle? I don't know. Well, that's annoying now because... I suppose I could put it back together and see if the same fault's occurring. Let's take this one off anyway. So I'm going to use a bit more flux. And we'll just use the hot air on it. Hopefully I won't melt everything else. What I'll do is I'll try to aim the heat this way. And then if I see these things turn a different colour, I can put some Captain tape on it. Right, I'm going to set the heat to 400 degrees, and I'm going to keep it quite low, 3 out of 8, because it shouldn't take a huge amount of heat on this board. So you can see I'm putting the heat completely the opposite direction to where those plastic connectors are. No, I think I broke that because this is down so well. I think just by bending the leg up I snapped it. Here we go. Yeah, I would have never got that off with the soldering iron. Look, you have to use heat on that. Okay, so I'm going to pop the one on from the other side. I might as well take those resistors off now as well that the board's hot. Don't even know where that resistor went. Tiny. Just going to look under the eye loop. Right, that other resistor stuck to that lump of solder here. Yeah. There it is, re-emerges. Excellent. Well, I'm very disappointed that I broke that one, because now I'm not going to know whether it was faulty or whether it was, you know, me. Because, for example, even when I change this over, I don't really know now whether it was the resistors or this MOSFET. So I'm going to have to try and change over those two resistors as well. They're absolutely tiny. They're going to be so hard. You know, you can't. When they're on your tweezers, you can barely see them. Right, I'm going to do the same thing again. This is going to be even harder because I've got this thing here, but I think I'm going to angle the heat just here, and hopefully I will miss it. Excellent. Okay, that came off really nice. So now I've got to try to get these back on over this side. So looking at the paths, I can see that basically this path here goes over to this resistor, and this path goes to this resistor here. So they do look like they're very important. Could have just been the resistors. Be unusual for the resistors to blow though, wouldn't it? I do have a pack of resistors, small ones, that I got from China, but I don't have any of these MOSFETs. Now let's heat that fella up. I think that's on, it's a bit crooked. I'm just going to have a look through the eye loop. It's sticking up a bit, so I'm going to heat it up and push it down. Right, that's in its place. So now I have to try and get these tiny resistors on. And with these it doesn't matter which way round they go. I hate flux because it just sticks to everything. And then you end up losing it. Let me get some more tweezers. Right, so they're in place. So what I'm going to do is I'm just going to lower down the heat, and I'm just really just going to hover over them and just try to get them seated. I'm not even going to tap them. I'm just going to let them do their thing, and then once it's cooled I'll tap them, and then I can see if they've made a connection or not. So I'm going to put down the, sorry, I'm not lowering down the heat, I'm lowering down the airflow so they don't blow away. So I'm just 2 out of 8, and I'll keep it at 400 degrees Celsius. I'm not putting any more flux on because you can see how sticky it all is here already. Do you know what? I should be able to tap the big one, and if the big one is seated, then I can do the small one. Yeah, there we go, that's in its home. Yeah, definitely. So if the big one's done, the small one's definitely going to be done. Right, so we're going to now clean that up with some IPA. Luckily I haven't burnt any of the connectors. And yeah, we'll have a good close look at it, and hopefully that side might well be working. If it is, I can put on 2 of the resistors. Well, maybe I can test the other resistors now that they're out of circuit, and I'll have to look to see if I can buy one of these ones. Okay, so they're all connected up now, so let's pop it over. I haven't put any screws in it yet. Let's plug this in and see what it does. Okay, turn it on. Excellent, look, it's not spinning. So now, let's put it back together more, and let's see if it actually spins when it's supposed to. Right, so here goes, it's missing everything from it, but let's just see if that starts spinning now, this side, when I press this button. There we go. Excellent. Yeah. And then that's just, okay, that's just probably because I've been lifting it up. Or it might be because it thinks something's blocked. Yeah, let's turn that off. I'm just going to turn this on here and let's see if it spins when it's docked. Or see if the spinning goes off when it docks, I mean. Right, here goes. Right, so it's working, it's come to the end. Oops. And then, there we go, that's what it's supposed to do. Wow, okay. I am happy with that. I really wish I hadn't broken that, because then I'll be able to prove whether it was the resistor or not. Maybe you guys will know by the meter readings that I gave you. Maybe you can tell whether that's a faulty MOSFET or not. Look what came through, 99p from China, my SMD ruler. So this will basically tell me what size they are, because if you have a look here, can you see 0201? And then let me zoom in. Right, so these are the tiny ones, 0201, 0402. So now if we get our bigger one of the two, the 202, I bet you that's going to be the 202 resistor. So you can see now that that's two. I wonder, does that mean the solder pads now, or is that supposed to be the actual shape of it? Do you know what I mean? Because that looks too big for that, but too small for that. But if that was the solder pads, that would be perfect. So now I don't know. Surely this must be the actual size of the item rather than the solder pads. So this looks like it's actually quite big. So, well, not really, is it? So this is going to be an 0402. Now I don't think I went as small. I don't think I bought any 020. No, I think I might have done 0201s. Right, so I need 0402, so the other one is going to be an 0201, which is the smallest of the small, isn't it? So, yeah, let me just see if I can find them. I bought basically just these kind of kits from China, where you get all different ones, you know, about a row of kind of 20 of each of them. Let me see if I've got the correct ones. Right, okay, so these are the 0402, the bigger ones, and if you have a look, this is 1K, and if you look what it reads, you can see that it reads 102. So in other words, what that means is 1 0 and then 2 more zeros. So that's 1000 ohms. Yeah, 1 0 and a 2 stands for 2 more zeros. So 1000 ohms is 1K. So I'll be happy that that is 1K. This one says 1K8, and if you have a look, this should be 18 then 2. Yeah, 182, 182. Yeah, so 1800. Now this is where it gets weird. 2K, which is the one that I need, isn't reading 2K unless it's just printed up wrong. So look at this one first, 2K2. So we know without even looking at the front that it's going to be 2, 2, 2, isn't it? 222. Have I got that right? Let's see. There you go, 222. Yeah. So this should be 202. Because it's then going to be 2000, which is 2000 kiloohms, which is 2K. But look what this one's labelled up as 308, which is going to be, oh, I can't work that out, 30 and then 8 zeros. So maybe this has just been measured up wrong. So what I'm going to do is let's zoom out. So I mean, maybe either more likely that this is wrong, but maybe they are going to measure 2 ohms. So I'm just going to, sorry, 2 kilo ohms. Let me just go here. I'm pinged off again. This is impossible. Do you know what would be really useful? If there was some kind of tiny little plastic clamp, so not a metal one because it was short together, but if there was a little plastic clamp that you could get, really fine, ceramic maybe, that you could just tighten up like this to hold on to something, so then you could get a good reading on them. I can't be the only one that struggles with this. Wow, so that is 2 kilo ohms. Is that not going to confuse the next person that comes working on this in years to come? I mean, I'm going to fit it, but that top is not reading 2 kilo ohms. Why is it not reading 202? Weird. So the back's labelled up correctly, but the top isn't. I mean, these are just very cheap Chinese ones, but again, if a factory's making them, it's they're not going to make them with all the wrong... You know what I mean? They must be making these in their millions. Unless that could be just me reading it completely. Maybe there's different scales you can use, and maybe this is some other scale. Because the thing is, the 3 doesn't really look like a proper 3. Let me zoom right in again. You know what I mean? Like a 3, but it's slightly, it's sort of rectangular. Some of the other 3s are nicely rounded. 3, but that definitely doesn't look like anything like a 2, a 0, or a 2, does it? Oh well. I hate putting in something that doesn't look right, because then it just means that in the future somebody could put in a resistor that's completely wrong. Then again, realistically, who's going to be doing component level repair on this in years to come? It's probably unlikely. Anyway, that's that one. Now I've got to see if I've got a 0201 in 56 ohms. So let's see if I can find that. Right, so with these ones I haven't got 56 ohms, but what I have is, looks like 22 ohms, 47 ohms and 100 ohms. So I suppose the closest is 47 ohms. I hope now that that isn't going to cause any problems by being a different resistance. Hopefully it'll be okay. So let's pop one of those out and see if it is actually reading that. Hopefully it might be a little bit high, which would be good. Right, so there it is. So let's zoom out and let's get a reading. 47 ohms. Okay. Well, I'm just going to have to go with that, I think. Right, I have had a thought. I have also got 10 ohm resistors, and if you were to add 10 ohms onto 47 ohms, you get 57 ohms, which is pretty damn close to 56 ohms. The only problem is I need to do it in series, and I'm not going to be able to do that on the board. But what I was thinking is, so unfortunately you can't do it in parallel because it's going to take the easiest path. So if I put the 10 down and then the 47, it's just going to all flow through the 10, because that's the easiest one to go through when they're in parallel. But if I was to do it in series next to each other, then that would add up to 57 ohms, which will be closer. What I'm thinking I could do is, on the board, pretend that this is the board here, I could put one resistor up here and then another resistor like this, because obviously I can't, there's not enough room to put them side by side. But if I was to do it like a triangle like this, then of course it's in series, isn't it? It's an option. It's just that it's so small, I don't know whether it's going to be possible to do it. But you know what, let's give it a go. If it's wrong, I've got plenty of spare here to you know, put the 47 back in. Maybe it doesn't make a difference if it is 47, it might work absolutely fine. It's just that for me it would be nice to get closer to the 56 if possible. And of course that is assuming that both sides are the same. They might not be. Maybe maybe the side that was faulty might, because remember the resistors were open, so I couldn't actually test them. I'm just going by the other side, but the other side might be completely different. I don't actually know that or not. Right, an easy way to test that is just to go from the same legs of the other MOSFETs to the same tiny resistors, and look, they're all coming up as 56. There you go, 56 on that one, another one here, 6 on that one, and this one here, 56, yeah? So it's a safe bet to say that they're all 56. Right, so what I'm going to do is I'm going to line this up, and I'm going to just try to do this by, I think I'm just going to try to do this with the soldering iron. I'll do the bigger one first. Now the reason it looks so messy is because of all the conformal coatings kind of coming off and going all lumpy and stuff. Right, let's zoom out now and let's see if we've got proper resistance between each of the legs and them. So we should have 2 kiloohms on one of them and 56 ohms on the other, but it's going to be 40, 47. So one leg, I believe this leg goes to here, so let's just check that for continuity. Yeah, so now let's go to the ohm reading. So if I go between here and this side of the resistor, perfect, 47 ohms. And if I go, yeah, 47 ohms. And now if I go between this leg and this side of the resistor, the big one, there you go, 1.9, perfect. So what I'll have to do now is go onto eBay and find out how much these MOSFETs cost. What I'm thinking is, in this job lot of 10, there's probably going to be 1 or 2 of them that are, look at them all. Now they are a different model. They're an older model. I think these are only 20 watts, and the one that I've got is 40 watts, so it'll be more powerful. But what I'm wondering is, there might be some in here that have a faulty main board, maybe the chip or something that I can't fix. So I'm tempted to quickly take one of them apart and then see if it's got the same MOSFET in there, because I bet the boards are very similar. If they have, I might nick one of them, and then when it comes on Monday, I can pop it back in, and that way I can get my video done for the weekend, and I don't have to wait all weekend for something, because I'm really impatient when it comes to waiting for stuff. So I'm going to pop one of these apart to see what the inside's like. I'm going to take this other one apart now. Now, I hope I haven't made a mistake there. I've bought 10 of them. I don't know how many videos it's going to take me to get through. I'm hoping you lot will like it. I don't want to make the channel boring, it's just that I think these are really interesting. So what I'll be doing is I won't do 10 videos on them. I might try to break it down maybe into 3 parts or something like that, because some of them might just need new batteries. So I won't maybe go into as much detail on each one, but I still think they're going to make, I don't know, personally I really like them, and I'm really looking forward to getting stuck into the 10. And I hope it doesn't mean that they're going to be boring videos, because for me, I've really enjoyed this one, this revisit, and the original one as well. So hopefully these will bring up some nice surprises and they won't be just boring faults. Wow, look at this. I haven't checked the board yet, but there definitely is MOSFETs on it, which is good. But look, I think I found a couple of chips or something like that. And also a nice bit of hair here. Right, I'm going to have a close look at these here. In fact, I can already see that it is the same. Give me 1 minute. FR9024N. So these MOSFETs here are the same. So I've taken the battery out, so there's no danger of anything exploding. I know good practice is to take it out completely, but this board doesn't need too much heat to get the components off. And I know there's plastic underneath, but I don't think I'm going to cause damage to the plastic underneath, because if you have a look, if I take off this one here, there's a big hole, yeah? This is the hole where the battery is. So basically, I'm only going to be heating up, and in fact there's a tiny air gap there anyway, in between that and that. So I don't think that battery thing is going to melt. Well listen, we'll live and learn. I'll give it a go. I know I made a mess before when I tried to take something out in the Nintendo Switch when it was still in the board, but I'm thinking I'm going to be okay with this one. Put a bit of flux on just to make it easier to come off. And I'm just going to use the same temperature as I did before, which is 400 degrees Celsius, and I'm going to go 4 out of 8. Let me check underneath, make sure I'm not melting it. Seems okay. It's coming. There we go, lovely. Right, no damage at all. Right, so I'm going to pop this back in here again, use a little bit of flux. I'm not going to go crazy with the flux, and I'm just going to take out that connector. Again, I'm going to try to do this when it's in the board here. What I'll do is I'll lift this up here and I'll put some pliers underneath it there. There we go. Again, I'm going to keep the heat away from that plastic connector. There we go, that's in its place. I am just going to add a tiny bit of solder just to the two legs here. There we go. I'm going to clean it up with a little bit of IPA. Okay, so there we have it. You can see the MOSFET that I just put on, and you can see the resistor. That looks fine, and this one is the bent one, the one that went on slightly crooked, but it's alright now. When I was heating up the board, maybe I should have just tapped it down with the hot air, but I don't want to tempt fate. They're testing okay. Right, I am going to now put this back together, and then let's see what's happening with it. Okay, so now let's test this MOSFET here. So first of all, before we do this one, let's do this one because we know that this side is working. So if we go there, you can see 0.56, and if I go to the same ones here, 0.56, and if I go onto that side, you got 1.46, and if I go onto this side, 1.48. So near enough identical. I think, fingers crossed, that this might be okay. Right, here goes. What do you think, yes or no? I think yes. Brilliant. Good so far. Now let's see if they both spin when we turn it on. Yes, excellent. Okay, turn that off before... Oh, I don't want to sweep up those screws. Right, let's... got my solder as well. Let's get this here. And now, let's see if it stops when I force it onto the dock. So they go in, and then we're going to go... Oops, we're going to... No, hold on. Let's try that again. Look at that. Fantastic. I am happy that's working. Let's do that one more time. So it's going, and then we're going to go up. We're going to go up into the dock. Brilliant. Oh, do you know what? I'm so happy. So happy with this one. I've thoroughly enjoyed... Turn that off. I thoroughly enjoyed doing this, and also the proper video as well. Do you know what I mean? I enjoyed both of them equally as much as each other. So let me just pop that back in there. There we go. I don't think I need to show you it working around the kitchen because you've seen it working last time. But that is so good. that that's not spinning anymore? All because of, what was it, a dodgy MOSFET and 2 resistors? Or do you think that maybe I was measuring that MOSFET wrong and it was just 2 faulty resistors? I mean, 100% the resistors had nothing between them. So the path coming, both of them coming out of the MOSFET, weren't going to where they needed to go because of the 2 resistors. So I wonder if I just changed those 2 resistors, would it have worked? Weird though how the MOSFET wasn't giving me the same reading as the other one. So I know I mucked it up by bending that leg up, but if I had to put money on it, but you will tell me in the comments, I think the MOSFET was faulty and I think the 2 resistors were faulty. That's what I believe anyway. But you know what, I'm often wrong. Yeah, so that is it. Thanks so much for watching. Sorry, I know I said that was the end of the video, but watch this. I haven't tried it on steps before, and look, it really does not go over steps. Look at that. How good is that? It knows not to fall down steps. Let's try that again. Watch. Look at that. It goes quite a bit over, but it won't go all the way over. It's fantastic. I love watching this thing. Honestly, I could watch it for hours. So good. I like it when it starts going around the edge of the room, so once it's done the middle it will find the edge and it will keep hugging the edge all the way along. Right, that's it for this video. Thanks so much for watching. See you soon.